Welcome to our end of the year Tech Talk. I am Xander Zoran. I'm a project manager at Phoenix National Labs. We are an FOC of ATS, and we want to talk about QA and QC in the industry regarding codes and the requirements and responsibilities for the owners and contractors. And we also want to talk about our experiences in delivering those inspections and requirements and what we've kind of experienced. With me I have two gentlemen. I have James Tarr to my right. He is 25 plus years in the industry. He's been a welder, a fabricator, and an inspector for us. And I also have Alex Zoran III. He is the co-founder of PNL. He's also a professional engineer. He is he has a level 3 in multiple methods, and he also has various other certs based on structural and pressure vessel codes. And so, you want to kick it off?
Yeah. So, one of the things I just want to say is the responsibility for quality starts with the owner. The owner and the contractor and the engineers. That team has to work together to establish what the quality requirements need to be and which codes and standards need to be followed. And so what we have found is sometimes there's a disconnect between those three things. And I think we're just going to talk about some of our experiences in dealing with the third-party inspections that we do where inspections are required independently. And that's what we are. We're an independent third-party provider of those services. So we have quite a bit of experience and quite a few stories. So we'll try to keep it as short as possible. But with that, kick it over to Jim.
Jim, what's one of your experiences you've had?
Well, I've had quite a few over the years, but the latest ones, we were at a large project, a sports complex, and they started putting the building together, and I noticed when I looked at the bolts, it was a bolting inspection and a welding inspection. We were doing both on this project, and I get up into the lift and I go up and look at the bolts, and I realize that the surfaces that have to come together, they're 3/4 away from each other, which is totally unacceptable because those plates have to be snug tight together once the bolts are tightened. So I got with the contractor and I said, well, this is unacceptable, what can we do? And because it certainly isn't safe for the building when nothing's touching together when you're that far apart. So eventually the engineer got involved and he made plates, shim plates that would go in, and it pulled everything together and everything tightened the way it was supposed to be. And the other issue with that is, as we looked at it further, he actually had the wrong bolts. They were supposed to be a higher grade bolt, and he didn't put the right bolts in. So whether he wanted to fix it or not, he had to change all the bolts anyways. So it was quite a fiasco.
So that's just an example of a contractor not paying attention to the plans and specifications and drawings, and so he installed the improper bolts, and he didn't even understand the process of how to bring the plies together, and that he was going to get inspected. And so those are stories that happen a lot with us, and we find that time and time again. So Jim, I think you had another story related to that with the welding and the weld symbols.
Oh yes, that was actually another project that we did. It was another big project. I went out to do welding inspection, and I got with my contact, and then I got with the welders, and I noticed that I said, well, you didn't finish welding the whole thing. He says, what do you mean? I said, well, the symbol that you have specifies that you have to weld that plate all the way around. And he argued with me and said, no, that's not what that means. That means that that's a field weld. And I said, no, you're incorrect. That you have to weld this plate all the way around. And we see a lot of that where we get to the sites And the welder, he doesn't understand the drawing, and he also doesn't understand the weld symbols. So that's a big problem, because we want to make sure everything is welded correctly, not just, well, maybe it's supposed to be like this. So.
Well, and that's a good story, because what happens in these situations is the contractor is actually responsible to do his own QC. So he obviously did not do the QC on this job, nor cared to. Instead, he just relied on the owner inspection, which is what we were providing as a third-party inspection, as a special inspection. He relied on that as his QC. Well, that's entirely wrong. That's a big problem right away. We should never be called out to a job site until the contractor or fabricator has done their quality check to make sure everything's right. We should just be an oversight, and it should be a simple inspection. Unfortunately, when that happens, now we know we've got a problem. There's nobody doing QC. Now we're going to look a lot closer. We're going to have to dig deeper and try to find out what's going on. So that's always a flag where they don't understand what's going on. So that's a good story for sure.
And another incident we had on another site was I went out to do the inspection. They were doing moment connections on this big building, and I got out there, and I went in. We looked at all the general notes and the structural notes with my contact, and then we walked out to the site, and I said, he's using the wrong process. And he says, what do you mean? And I said, we just read your engineer's notes, and he required that he wanted SMAW, low hydrogen, and you guys are running, 211 wire. He said, oh, Jim, I didn't know they were doing that. I said, okay, well, tell him to stop. So he had the welder stop, and he went, called the engineer, and the engineer was on speaker, and the engineer said, that's okay, I'm going to approve that. So then we moved forward with it. But like Alex brought up, he never gave us a procedure. He never gave us a procedure for that wire.
Right. The NR211 is, the contractors love it, fabricators love it. It's a really easy flux core. It is a low hydrogen process, so it qualified, and that's why the engineer accepted it. However, it's come to prove, the manufacturers of the NR211 have come to prove that it really doesn't work well for thicker sections of material. So for moment welds, that's probably not a good idea. Maximum thickness for NR211 is going to be a half an inch, I believe. And I think that's a Lincoln product, and I think Lincoln even wants to keep it below a half inch, if not 7/16 or something. So the very limited use of NR211, which brings me to another story that we know about with NR211. We were called out to inspect some light poles that had been cracking at the bases. And we went out and checked that out. And sure enough, we did a bunch of mag particle. We found a bunch of cracking at the bases. And then the city that we were working in asked us to try to figure out, well, what's the cause of this, because they had some failures. And so we started investigating, and we were able to get to the manufacturer's facility and see what they were doing and monitor their process just to get a feel for how they were welding these things. And the first thing that we noticed was they were welding with NR211. Well, the base plates were an inch thick. You cannot weld NR211 anything over a half inch. So that was really the primary reason why these things were cracking. And they ended up having to replace a whole bunch of these poles, and I think the fabricator actually got delisted. So that was kind of a problem. But NR211, it's a great idea, but it really doesn't work well code-wise. So that's kind of an improper usage of welding and different welding processes. But I also have a story about improper use of NDT methods. So at a chemical plant, we got a call. They had a leaking production line that they had just newly built. And so we asked a little bit about the background story, what's the scope, what are you guys looking for? And so we found out that a different company had went out there and done phased array on thin wall stainless.
And so they wanted us to go out there and do phased array to verify. And we said, no, we're not going to do that. Here's why. You need mock-ups for the code, special probes, unit softwares. There's a lot that goes into doing stainless steel phased array, especially on ultra-thin. So we recommended radiography. So we went out there, and you could see there were spots where it was leaking. So we x-rayed them, and they had some corrosion going on because they used some city water for the hydro, and they actually left it in there. But we also found another major problem, which was that there was an insane amount of weld discontinuities. IP and IF run throughout all these pipes. So we ended up having to, on the dime of the owner, we x-rayed 90% of this entire system, which is about 400 welds, and we found about a 65% weld reject rate. And so they ended up replacing all of that lines, and there was a bunch of situations where there was no QA done by the owner, no QC done by the general contractor. Everything was welded by a subcontractor. And so we ended up finding out they cut a bunch of corners. They just butted up some welds, and they just did a flux core cap with stainless, and it was just IP riddled throughout it, and that's where all the corrosion was attacking. And so they ended up rebuilding this entire system, which cost us a lot of money.
Yeah, so I think there's a couple things going on here. First, there's a misappropriate NDT method. Mm-hmm. And we argue all the time about doing ultrasonic exam on stainless steel. The codes have recently gotten a little bit stronger. They're very specific about how you have to do that. And it is a very cumbersome process. But unfortunately, you get not only contractors misreading the code, you get other inspection firms that say, oh yeah, we can do that, and they just go ahead and do it, and it's inappropriate. So that's one problem. I think another thing that just prompted me on another story that I remember about the welding, just butting the pipe up and welding around. We had another project where it was a gas pipe at a school, and this was many, many years ago. And the contractor called us out to do inspection because somebody had made them. I think one of the city officials had said, hey, you got to get inspection on this pipe. So he just assumed it was visual, so he called us out to do visual. So we sent a guy out to take a look at it, and the welds looked great, except for what he really needed was x-ray. So we had informed him, we said, well, look, you got to have x-ray here. So they said, okay. So we went ahead and x-rayed, and I think there was like 30 welds or something, 100% failed x-ray. What they had done was they just butted up the pipe together, no bevel, no preparation, and they just put a seal weld on it. Contractor was and he wanted to bury his pipe. And so that was expensive for him. He had to go in, cut every weld out that he had put in, re-bevel it, re-x-ray it, and he had to pay for it on his own. So that was an expensive lesson for sure. Okay, you guys have any other stories?
You got anything else, Jim?
No, my big thing is when you go to the site, you got to read them notes first before you move forward and do the inspection, because you might think, well, they're just doing 70-18, but then if you look at the engineer's notes, you'll say, oh, that's not what he wants at all. And a lot of times the welder has already started welding, and nobody has even read any of the notes, So it's important to read those.
Well, and the specifications. I mean, quoting out a lot of jobs, I'll ask for as much documentation as I can get so I can understand what the engineers are intending for the design and the inspection. And so a lot of times contractors will give me specifications that they probably may or may not have read, and I'll find out that there is a specific method or requirement for inspection, whether that's periodic or continuous or something in that nature, where the way that they're asking me to quote it isn't correct. And so I'll have to notify them and tell them, hey, no, this is what's required, and this is in the spec for the job, this is how we have to proceed. And so there's a lot of times where I'll catch that even on the quoting side to try to help the general contractors or the owners make sure, it gets built correctly.
Well, yeah, that brings up another good point is people don't understand what periodic inspection is or what special inspection really is. And so a lot of times they think that's partial inspection or a percentage of inspection. But for welding, and I've written this in my code corner multiple times, it's 100% weld inspection is required. And on top of that, you have to do periodic checks of in-process welding. and check fit-ups and weld procedures, and the welders are qualified. And so what happens is they call us out at the end, and they say, oh, we're all done, we just need a final visual. It's like, well, no, that's not going to get you a special inspection stamp on your certificate. So you have to be aware that there's a lot of aspects to the inspection process, and as a third party, we're going to quote that correctly, and for a lot of reasons, we won't get that job because other people are not quoting it correctly. They're not doing the inspections like they're supposed to. So, anyway, you have anything else, or
no?
Closing sessions?
Yeah. Well, I have two stories I want to talk about.
All right.
That I think are interesting. These were both projects that were litigated and that I got involved with as an expert witness. And the first is not understanding what the codes and not understanding what the drawings, as Jim was talking about. You have to understand what the drawings are and what the specifications are, and when you quote the jobs. And that's why we're always asking our clients, what is the code? What's the standard? Can you send us the specifications? Nobody ever wants to send us anything. So we got to pull it out of them, get us the specifications and the codes, because we want to make sure that we're doing what's supposed to be done. So in this particular case, it was a gas pipeline at an airport, and this was not in Arizona. This was outside the state. And what happened was the project got audited by an engineering team about 6 months after the job was over. They had already put the fuel lines in, buried them, they were underground, buried them, poured concrete, asphalt, all done. And this auditor goes in and he says, hey, you guys x-rayed this pipe, but you x-rayed it to API 1104. The contract says that this will be x-rayed to ASME B313. So I got a problem here. Mm-hmm. So he went back to the contractor who was responsible for providing the NDT, and of course he had hired out a third party. The third party got wind of it, and they said, they took their reports and they just said, they crossed out 1104 basically and whited it out, typed in ASME B313. Well, the engineer got that and they said, wait a minute, this I don't think this is right. So that's where they got me involved in it. They said, hey, is this right? And I go, no, it's not right. There's a lot of differences between B313 and API 1104. The radiography procedures are different. The acceptance criteria is different. So it created a whole big mess of, look, you guys didn't do this right. So now what do we do? They talked about digging up this pipe and re-x-raying it, maybe sampling a weld. Ultimately, they didn't end up digging it up, but there were some concessions made. The contractor had to give additional warranties. They had to give, I think there was penalties and fines. And not to mention, several attorneys were involved. So there was a big cost in trying to figure this whole thing out. So it would just been simple to have read the specification and know what the code was at the beginning. This is why we're always telling our guys, let's get it in writing. It's really, really important. And then I had another story that I ended up getting involved in a litigation, and it was similar to the leaking one Xander was talking about, where they had installed a bunch of pipe and it had been in there about 6 months and it started leaking. So they were like, hey, they called me up. They said, hey, can you tell us why this is leaking? And I looked at it and I go, yeah, I could tell it was bad welds. And so they had made a resistance welded pipe, and we did the metallurgical evaluation and the analysis, and we said, oh yeah, you've got bad welds. So they said, okay, well, how did this happen? And I was like, well, who was the manufacturer? Well, the manufacturer happened to be here in Phoenix. This project was actually out of the state as well. It was in San Diego, I believe. And so I said, well, what I'd like to do is go down to the fabricators and see what they're doing. Be able to monitor their process and their system and find out, what happened. So they allowed me to come in there and take a look at it, and I monitored their process. And they had a QC department, and they were they were doing all their mechanical tests and their flattening, at least when I got in there. They were doing what they were supposed to do. And they had an inline system. So electric resistance weld is an automatic process, and they weld a lot of pipe really quick. Basically, you take a sheet of flat steel and you roll it through an anvil, and you have a resistance spot that welds that together, and it flies through an automatic system. It's a really fast system. And then they have a coil right after the welds, eddy current coil, and it monitors the weld quality. And so if it's bad, it alarms, and it's supposed to paint a spot on where the bad spot is. Well, I guess what was happening, and I'm sitting there watching this whole process, and I'm talking to the technician, and I go, well, how does this work? And he goes, well, when it's bad, the alarm goes off. And he goes, but I turn it off because it bothers me. So I just turn off the alarm. So it was like, all right, so what is the point of having the eddy current, right? So that was, again, it was an inappropriate application of NDT method. So he never actually did the inspection because they just ignored it. So they could have had bad pipe everywhere, right. And that's what happened. And so they submitted all this pipe, and it was bad. And so that turned into a big mess. So they had to replace all this pipe in this whole process, and it was expensive as all can be. So that's another misappropriation of NDT method. And so with that, that's all I have. I think in my code corner this quarter, I'm going to discuss who's responsible for quality and how that works. So if you get a chance, go to the code corner and read up on how that process works.
Yeah, thank you. I appreciate all the stories. I think that was fantastic. We are just here trying to help give knowledge to all of our clients and contractors. We just want to better the industry, is what it comes down to.
Exactly.